In this video, we are going to use a computer-aided design program called Fusion 360 to explore properties of parallelograms and how applying different geometric relationships to a quadrilateral gives us different types of parallelograms. To begin with, I am going to draw a simple quadrilateral. I'm going to try to make sure that this quadrilateral does not meet any specific criteria for specific kinds of quadrilaterals. So if you recall from your class, a quadrilateral is simply a polygon with 4 sides. And as you can see, we have a polygon with 4 sides. To make this quadrilateral into a parallelogram, we will use the definition of parallelogram, which is a quadrilateral with opposite sides parallel. That means I need this segment right here to be parallel to this one down here, and I need these two to be parallel as well. In Fusion 360, there are things called geometric constraints. And we can use that when we're designing things to apply specific geometric relationships. Right now, I'm hovered over the parallel constraint. And what this will do is it will take any 2 lines in my design and force them to be parallel. When I select that constraint, I can choose any 2 lines. And what Fusion will do is it will move one of the lines in order to make it parallel to the other. So if I click this line here, and this line here, it adjusts those lines so that they are parallel. When that happens, you'll notice this symbol appears. This is a parallel constraint, and it tells the engineer doing the designing that those particular lines are parallel. It's not unlike in geometry class when you mark parallel lines with specific symbols. Now I need the other 2 pair of opposite sides to be parallel, so I will do the same thing. I will click one and then the other. And now I have a parallelogram. Now you might notice that the same symbol is showing up for the new pair of sides. So unlike geometry class, when you might alter the symbol, say by drawing like a hash mark through that, this is showing you one symbol. But if I hover over one of my constraint symbols, you'll notice that the paired constraint symbol will also highlight. So this is Fusion's way of letting the engineer know which 2 lines are parallel. If I hover over this constraint symbol, you'll see that its paired will also highlight. Now we have a parallelogram. And with that come all of the features of parallelograms. So among those is that opposite sides are congruent or have the same measure. I'm going to use the drop-down menu here where it says measure, and this will simply bring up a kind of ruler where Fusion will measure the side lengths for me. If I click on opposite sides, you'll notice that Fusion will measure them and that they have the same measure. Now, Fusion does not know what I am trying to do. So Fusion also gave me the measure of the diagonal across the parallelogram. But look at the 2 side lengths. We have a side length of 2.996 inches, and the side length of selection 2 is 2.996 inches. If I wanted to, I could do the same thing with the other pair of parallel sides and confirm that they too have the same length. In this case, it's 4.641 inches. So we know when we made opposite sides parallel that we also made opposite sides congruent. Now suppose I want to take my parallelogram and make it into a rectangle. Well, to make a rectangle, we need the angles to be right angles. In our constraints panel, you'll see that there is a constraint called perpendicular. This will give us a right angle. This will take any 2 lines on a design and make them perpendicular to each other, even if they're not touching each other. I will choose that, and then I'll pick 2 adjacent sides of my parallelogram, say these 2 sides, and Fusion will make a right angle at the junction of those 2 sides. Now you'll notice that a perpendicular constraint appeared, and that lets the engineer know that there is a perpendicular constraint between those 2 sides. Now, when I did that, you'll notice that all of the angles became perpendicular or right angles. And that, again, has to do with the properties of parallelograms. We know that same side interior angles of parallel lines are supplementary, which means they add up to 180 degrees. The moment I made this a 90-degree angle, knowing that the lines were parallel means that this also needed to become a right angle, and so did the other angle adjacent to it. And once these were forced to be right angles, then this angle down here was forced to be a right angle as well. We also know that in a parallelogram, opposite angles are congruent. So now we have a rectangle. Notice that it's still a parallelogram because opposite sides are still parallel. Now suppose I want to make this rectangle a square. Well, a square is a rectangle but has all congruent sides. That means that I need these sides to be of equal measure. In Fusion 360, there is something called an equal constraint, and that will make any two sketch entities, they could be segments or angles or arcs, and it will make them equal in measure. When I choose that, I can choose two sides, and they will make them equal. And you'll notice a new constraint has appeared. That is our equal constraint. And because we know opposite sides are already the same length, we already demonstrated that, this automatically has to be equal in length to its opposite side and vice versa. And I have now built a square by applying different constraints to my quadrilateral.